Hello, in this video we want to talk about LED blinking, the circuit which is a mother science of PWM, ADC and oscillation. But what does it do? What is the functionality? Let's start. At first, we can see there is a resistor, an LED and a BC547 transistor. This transistor can act like a micro switch. So I can put it here, then click it on and off. But when I take it out and put a transistor, the base will be triggered with a lower voltage. But how? We want to have a blinking LED automated system, as in pulsing in a cycle with these capacitors. So these capacitors are the role makers. So when the collector is connected to the GND, via base trigger. So when it is connected to GND, you can see the capacitor will be discharged. So in this way, the voltage here, B2, will be dropped. So in this way, this LED will be off and this one is on. But in the next cycle, the C2 will be charged because the collector is not really connected to the GND and it is waiting for the discharging of the C1. So in this way, when we are connecting the base like a key switch to the capacitor via a resistor, this one should be charged. When it is charged, the difference between base and emitter voltage difference or potential difference is 0.7. More than this, we can connect the circuit and the circuit will be closed. So when we have a collector which will be connected to GND, seems like connecting the capacitor to the ground. So it will be discharged. So when it is discharged via this connection, the first connection, the base 2 will be dropped and vice versa. And for more extra, the BC547 drop voltage is 0.2 up to 0.4 volt. If you want to accurately, for example, design a circuit in an advanced mode. So this one and this one is like a charger of the bases in a reverse connection. One for the base 1 and another one for the base 2. This capacitor will be charged and this one is closed. Then when it is closed, the collector will be connected to GND and this one will be discharged. Vice versa, when it is done, we know that this is the blinking and it can act like a temporary memory. So this is the working of how to with blinking LEDs. We have resistor here 447 or maybe 470. There's no difference. We can use it, or maybe 20 kilo ohm, 22 or whatever we need to charge up and discharge up these capacitors. So when you wanna charge or maybe turn on an LED, when you put a resistor, the brightness will be lower. And even if you connect the capacitor with a resistor, the charging will be slower. So this is the idea and critical key of making an LED blinks. Now is the time to wrap up and connect the circuit, the pins together, and show you how does it work. Here you are. This is a circuit, and you can change the amount of capacitors and resistors. And this is the much fast, but we can make it slower. And one more extra, the charging and discharging formula of the capacitor can be VCT Vmax times 1 minus Nper powered by minus T, the time, divided by RC. And discharging can be VCT Vmax times Nper powered by minus T RC. Now is the time to calculate the charging time. For example, our capacitor is 10 microfarad, so it is equal to 10 times 10 powered by minus 6 farad. And R times C, which R is 10 kilo or 10,000 ohm, times 10 times 10 minus 6 can be 0.1 time cycle, which in the calculation we have something like minus 0.1, which can be minus 10. So in this way, VCT can be 5 volts times 1 minus 0.0000454, which is equal to VCT. In 1 second, it can be charged up 4.99 volt. This is the charging. This is the charging voltage in 1 second. So we can say it is 99% charged up. Please subscribe my channel, thumbs up the video, and stay tuned for the next video.